Welcome to Homework Lib.
Hi, so for this question we're dealing with carbonic acid, H2CO3, which has a pKa equal to 3.49. That means that the value for Ka will be 10 to the minus 3.49. Remember that pKa is equal to minus the logarithm base 10 of the value for Ka. And the reaction that we are studying is the first pKa of this compound generating HCO3 minus plus H2O plus. We're going to go ahead with our ice table, and we're going to call the initial concentration C0, that is 8.87 times 10 to the minus 2. Let's call it directly C0. Okay? With this, in our ice table, the amount of change, the amount that is going to react, we're going to call it X. So an X portion reacts. Remember that water doesn't matter because it doesn't enter into any equilibrium equations. We initially have 0 of each of these ions. So we're going to produce plus X and plus X of each of them. At equilibrium, we're going to get C0 minus X, X, and X. Next up, this corresponds to the acidity constant of the acid, defined as the concentration of HCO3 minus times the concentration of H2O plus divided by the concentration of H2CO3. Replacing the values that we found at equilibrium, this is going to be X times X divided by C0 minus X. So now we have two different options. The first one would be to plug in the values and solve for X, solving the full quadratic expression. And the other one is going to be doing an approximation. So I'm going to give you what is going to be the result with both of them. The approximation that we're going to make is that C0, it is going to be much larger than X. That means that C0 minus X is going to be approximately C0. Under that approximation, Ka is equal to X squared divided by C0. Thus, X will be a square root of C0 times Ka. Plugging in the values that we got, this is a square root, initial concentration 8.87 times 10 to the minus 2, multiplied by Ka, that is 10 to the minus 3.49. We find a value of X corresponding to 5.3, 5.36 times 10 to the minus 3 molar. And this would be equal to the concentration of HCO3 minus, because we found that value from our ice table in molarities. Now what would happen if we solve the full quadratic expression? The result of X that we get is of 5.2 times 10 to the minus 3 molar. And as you can see, these results do not vary that much, and we can say that the concentration of HCO3 minus, it is going to be essentially 5 times 10 to the minus 3 molar. And that would be a correct answer. Okay? So that would be all. Thank you very much, and have a good one.